Hello, in this video I'm going to show you two special cases, of two special right triangles. Okay, remember the special right triangles are 30, 60, 90, 45, 45, 90. They're very special. So, here's what I have for you to consider. Please recall that for a 45, 45, 90, 45, 45, 90, that would make that isosceles right triangle. The ratio amongst the three sides will be x to x to x root 2. The hypotenuse will always be root 2 times, this guy is always root 2 times the two legs. Okay? For a 30, 60, 90, the side across from 30 being the smallest, because it's across from the smallest angle, we're going to call x. The side across from 90 is the largest side, so we're going to call that 2x. And the side across from 60 is going to be in the middle, and that's root 3 times the smallest side. So both this guy and this guy refer back to x being the smallest across from 30. So the ratio amongst the three sides would be x to x root 3 to 2x. Side across from 30, side across from 60, side across from 90. Okay? And again, here's your highlighted hypotenuse, the one across from 90. Alright, so that said, here are two special cases to consider. Okay? And both of these cases have something in common. They both have hypotenuse of 1. And we're going to use this in the context of trig tomorrow. So these triangles numbers we will get to know very well. So let's first consider this 45, 45, 90 triangle with hypotenuse 1. And then we're going to consider a 30, 60, 90 triangle with hypotenuse 1 as well. And so in both of these cases we're trying to evaluate the other two sides. So for this case, 45, 45, 90, I know my x root 2 side, right? The side across from 90 is x root 2. The other two congruent sides we're going to call x. So if I know x root 2 is 1, what I want to do is solve algebraically for x, right? So if I know x root 2, I want to isolate x. So I do that algebraically. So x root 2 equals 1. So if I divide both sides by root 2, I get what x is. So x here I have isolated, oops. And x is of course equal to 1 over root 2, but you know what, that's not really all that snazzy, right? Because I got an irrational number in the denominator, so I got to rationalize the denominator by multiplying by 1. And the form of 1 that I choose is going to be root 2 over root 2, because 1 times root 2 on top is root 2, and root 2 times root 2 on bottom is 2. Okay, so that's what x is, right? X, if x root 2 equals 1, then x is 1 over root 2, which is the same thing when rationalized in the denominator, root 2 over 2. Right? So there's my x side, root 2 over 2. Okay? Also, what I want to consider is a right triangle with hypotenuse 1. And remember, that's my 2x side. The side across from 30 would be half that, and the side across from 60 will be root 3 times whatever x is. All right, so this one's a little bit easier, because if I know my hypotenuse is 2x, which is 1, half of that is going to be x. So therefore x is going to be 1/2. Right? If 2x is 1, then x is 1/2. Which makes x root 3 1/2, because x is 1/2 times root 3, and we call that root 3 over 2. Okay? So the three sides of my 30, 60, 90 triangle with hypotenuse 1 will be 1, 1/2, root 3 over 2. The three sides of 45, 45, 90 triangle with hypotenuse 1 will be 1, root 2 over 2, root 2 over 2. Okay? So to summarize, two special cases, ringy-dingy, of these right triangles with hypotenuse 1 look like this. And here's my old 30, 60, 90. Bam. Okay? What I want you to do is learn these and have them understood for tomorrow's class, so we can indeed use them within the context of trigonometry. Thank you. Bye-bye.